Okay, here we are, the last chapter of the year. We'll see how far we get through it. Starting in section 9.2, we're only going to spend one day here. What we're going to do is learn how to integrate something that we've been using function integrate for all year. And it is the product of two functions. Like say we had the integral of x times cosine x dx. We've never been able to integrate when we had a function times out of an integral, and that's the process we're going to learn how to do today. The process is called integration by parts, and we're going to develop that right here. So we're going to go through the development, integration, by parts. Okay, so let's say we're starting with the function y equals two functions multiplied, u times v. Okay, the first thing I want to do is go through and get derivative. So derivative of y is y prime. Here we do a product rule for derivative. So it's u prime times v plus u times v prime. Okay, now all I'm going to do is switch these primes out for the differential version of it. Y prime would be dy. U prime would be du. And I'm going to flip the v in front. So I'm going to commute these because they're multiplied. The order doesn't matter. So I'm going to switch the order and make the u prime du, derivative of u. Here I'm going to leave the u and switch the v prime to dv, derivative of v. So this is the book notation. I just know you know the prime stuff okay. All right, what we want to do now is integrate all three parts. So we're going to take the integral of dy equals the integral of v du plus the integral of u dv. Now I would like to solve for this one. I want to get the integral of u dv equal to the other stuff. So I'm going to bring this to the front. Well, pretend, I guess I'll just subtract this. I'll do it that way. So I'm going to subtract the integral of v du from both sides. So now I am left with the integral of dy minus the integral of v du equals the integral of u dv. Now I want to look, are there any of these that I can actually do the integral of? Well, if you think about it, I've just got an integral of dy. I could have a 1 here. So what has 1 as its derivative? If I've got a 1 dy, that would be y. So this turns back into y. Minus this I can't do anything with, because these don't match, so I can't do anything there, and these don't match, so I'm going to leave it. And what I can do now is resubstitute what y was equal to in the beginning. Y was equal to u times v. And I'm going to flip this whole thing around. So my integral of u dv equals the y is uv minus, then this integral stays. Right here is our integration by parts formula. So if I've got the integral of u times the dv, and you're going to see we're going to be picking out the u and the dv here. That's going to be the trick. Equals, and then we follow this pattern. I'll take the u, multiply by the v, minus the integral of the v times the du. So in selecting the u and the dv, there's two things to remember. The first thing that's important, first, whatever you pick to be dv, dv must be integrable. You must know how to find the antiderivative of it. So it must be something you can integrate. And the second thing to keep in mind to help you out is the u should be something that gets simpler as you take the derivative. So u should get simpler, more simple, I don't even know, simpler as you integrate. Excuse me, as you take derivative. Okay. So if none of that made sense, that's all right. You don't have to worry about this development of this formula. We're just going to use this formula. And we're going to go back and do that very first one that I gave you, the integral of x times cosine of x dx. I think I can fit it here. So x cosine x times dx. So I actually have three things multiplied out there. X times the cosine of x times the dx. Okay. First thing, dv must be something I can integrate. So see the two functions in here. I've got x and cosine x. I can take the derivative of x, no problem. That goes to 1. The integral of x. And I can take the integral of cosine, not a problem. So which one of these gets simpler when I do derivative? Well, x is going to get simpler when I do derivative because that's going to go to 1. So I'm going to choose to let x be the u, and all of this stuff, the cosine x dx, I got to include everything, to be the dv. So off to the side, I'm going to let u equal x. I'm going to let dv equal cosine x dx. All right, if I look at my formula now, I need to know what u is. I got it, that's an x. I need to know what v is. Well, I don't quite have v yet, but if I do the antiderivative of this equation, I'll have v, because watch what happens. I'll do the antiderivative here and the antiderivative here. This is just like I had before, where I've got like a 1 dv. So what has 1 as its derivative? With a dv on the end, that's going to be v. So the antiderivative of dv is v. Derivative of v is v prime. Now that's dv. So now, what has cosine as its derivative? That would be sine. And don't forget the plus c. So, if I look back at my formula, I need u. I've got it. I need v. I've got it. It's sine x plus c. Integral symbol, I need v. Got it. I need du. Oh, well, if I do the derivative of u here, I'll have it. So remember, u prime is du. But I'll write it to match what's there. So du equals the derivative of x is 1. And we'll throw the dx on and do it like a differential. So I've got everything I need to plug into my integration by parts. So this integral will equal, according to integration by parts, I need the u, which is x, times by the v, which is the quantity sine x plus c, minus the integral of v sine x plus c times the du. The du is dx. See how I have x's all the way through everything here? That's what we need. Okay, the easy way to remember this is it's kind of a little cross product. It's u times the v, so it's those two terms multiplied, my x times sine x plus c, and then it's the integral across here. I integrate these two things multiplied, sine x plus c times dx. And it's that diagonal multiplied integral across. And you'll see in a minute. Okay, so we're not done yet. I still have an integral here. I'm going to distribute my x, though. So I get x times sine x plus x times c, cx, minus, I've got two terms in here, so I'm going to use brackets or parentheses, doesn't matter. What is the antiderivative of sine? In other words, what has sine as its derivative? If you needed to pull out that blue sheet and restore it, you can. But cosine's derivative is negative sine, so this must be a negative cosine. And what has c as its derivative? That will be, think of it as a constant. What has 2 as its derivative? If there was a 2 here, it would be 2x. If there was a 5 here, it would be 5x. Well, there's a c here, so it's cx. And then I've got a plus a constant from this integral that's different than the constant over there, I'll call it C2. Okay, I have all my integrals gone. All I've got to do is simplify what I've got here. So x times sine x plus cx. Distributing the negative, I'll have plus cosine x. Then I'll have a minus cx. And then a minus c2. Okay, in my line, my cx here and the minus cx are going to cancel out. And take a look, where those two terms came from was the sine of x plus c. These ended up canceling each other out. And that's the c that happened over here on this integral. We're not going to have to put that plus c here. The only c we're going to need is after we integrate the whole thing. There's a c on the end. And it doesn't matter whether you say plus or minus. So our final answer is x sine x plus cosine x. I got a minus c2, but it doesn't matter whether you put a minus or a plus. It's some constant that we don't know what it is anyway, whether it's positive or negative. So they usually just put plus c. Okay, we're just going to practice this technique here of integration by parts. Picking out the u, picking out the dv, knowing what to do over here, and then the multiply and integrate steps. Once you do a few, it's not bad. It looks complicated, but it's not too bad. Okay, number 2. Take the integral of 3x times e to the 2x dx. So again, I see an x times another x term. That's the product. That means integration by parts. So you have to be able to pick out your u and your dv. The dx is always going to be attached to the dv part. So remember that the rules are dv has to be something you can do the antiderivative of, and the u should get simpler. Well, 9 times out of 10, the x term is your u, so I'll let u equal the 3x. And then whatever isn't an x is the dv. And you go over here. If it doesn't work, then you switch it around. But like I said, 9 times out of 10, the u is the x term. So we'll let u equal the 3x. And we'll let the dv equal e to the 2x dx. Okay, if you remember from the other one, what I had to do to each of these, I needed to know what du was, so I do the derivative on this one. So derivative of both sides. Derivative here is 3 dx. Over here, I needed to integrate both sides, so that would bring me back to v. So I integrate and integrate. Remember, there's a 1 there. 1 dv, that integrates to v, equals integrating e to the 2x. Again, you have your blue sheet handy. Here it is. Remember, integrating an e term, e to the u, it integrates to itself if you've got the u prime attached to the du. So the u, the derivative here is a 2. So that means I need a 2 here, which means I would need a 1/2 in front of the integral. So now I've got 1/2 e to the 2x. The plus c we just talked about on the other side, that's not needed. I can just not even bother with that. Okay, now how does the integration by parts formula work? Well, you don't have to keep looking back. It's these two multiplied, and then the integral of these two multiplied. So, to get this antiderivative, I need 3x times 3x times 1/2 e to the 2x plus the integral of this times this. So 3 times 1/2 is 3/2.